coffee break on my indoor balcony. That's nice. And I like my light switch here. What I don't like is the lamp. I've made this thing a couple of years ago out of a glass, but to be honest it looked out of place, so I want to make a new lamp which fits the mood of the coffee break balcony, and that's what the video is about. And I already started with the build process of the lamp, and to make a video out of it was a spontaneous decision, so please apologize that I don't have all the footage. So here is the main part of the lamp, a mocha pot. I removed the internal pipe and I've made a aluminium plate, and I screwed a LED chip, 8 watt 12 volt LED chip onto it, so this will hang upside down like this. And I already made the base of the lamp, which is this thing. This thing goes again upside down on the ceiling. It's made out of pallet wood. It was a shipping crate, actually, plywood. And here in the back I have enough space for the dimmer electronic and all the wiring. Now I'm waiting for some teacups to arrive. Here are the cups, and I think I will use these two guys here. And to drill the holes for the cable to go through, I will use my Dremel knockoff tool with a diamond coated drill bit, and of course a bit of ordinary water. And I know from experience that 2-part epoxy sticks very well on glass. And since there is a bridge rectifier on the circuit board, I don't have to take care about the polarity. and a piece of conduit makes a perfect lamp holder. Now I have a place to hide the cable, at least in theory. Let's see how it works out. Cable ties are the maker's best friends. I always wanted to do that. Now let's find the right placement on the base here. Here's the main lamp. I think it should be right about here, so next to the wall, and then one cup somewhere here. And the other cup there. Looked right to me. Not so good for the breadpoint bit, but who cares? Here's my simple solution for adjusting the cable length, and I left a piece of extra cable just in case. So here's the chandelier, and I think I will stick with this configuration. Okay, so here is the circuit diagram of the dimmer. It's a classic microcontroller and MOSFET circuit. So let me quickly go through the components and what they are good for. Here is my 12 volt incoming supply from my transformer or SMPS. The power goes through a fuse, a 600 milliamp fuse, which is this one here. Goes through a diode, reverse polarity diode, which is on the back side of the board, this diode here. Goes through a smoothing capacitor, which is this one here. Feeds the voltage regulator, 5 volt voltage regulator 7805. In this case it's a surface mount component here, voltage regulator. The 5 volt gets again smoothed by a 220 nanofarad capacitor, which is this one here. And I have a control LED with a 220 ohm resistor. This is the green LED here with the resistor. So this LED shows me that the 5 volt is present on the microcontroller. And furthermore, we have a 2 nanofarad decoupling capacitor, which is this tiny one here for the microcontroller. So all of this stuff here is just for the power supply for the ATTiny 85 itself, which is here, 8-pin microcontroller. You could also use a ATTiny 15 or whatever would be plenty enough for the purpose here. Then we have the push button to set the dimmer, which connects to these 2 terminals here. There is a filter capacitor, which is this capacitor here. It's for debouncing, and a pull down resistor 10K, which is there. Okay, here it is, the back side of the board. The input pull down resistor to keep the input low as long as no signal is coming from the push button. The output goes via a 150 ohm current limiting resistor directly to the gate of the MOSFET. This guy here, again, it's a surface mount MOSFET, which I soldered onto a piece of copper as a heatsink, and of course a MOSFET. By the way, it's an N-channel MOSFET, and of course a MOSFET needs a pull down resistor to discharge the gate, which is a 10K resistor, which is this guy here. On the output side we have a fuse, 3 amp fuse, which is this fuse here. Again, a LED with a 1K resistor. This is this LED here, which shows me how bright the lamp gets. And I've drawn the lamp as a classical lamp, but in reality it will be 2 or 3 of these guys here, LEDs. So all in all they will draw about, I don't know, 1 amp, maybe 1.5 amp, so no big deal for this MOSFET. And I've tested it already. The MOSFET stays stone cold, and I guess you could use any kind of MOSFET, probably a logic level MOSFET would be a good choice. By the way, I've also added a ISP header, this thing here, so that I can program the chip in circuit, which is the reason why the circuit board looks so cluttered, because I had to route all these wires also to the pins of the microcontroller. And for programming the chip, I use my homemade ISP programmer. It's connected like this, and I can program the ATTiny via the Arduino Nano here. I think it's time to test it. Here it is. I hooked it up to my power supply here, 12 volt, 3 amps, and so let's test it. The slide here, So I push the button, it goes to the modes again, and so I can step up and increase the brightness of the LED. And if I stay longer on the button, it goes off. Again, 1, or you could simply stay on the button and it fades through all the steps. And wherever you stop pressing the button, the light will stay in this state. Now I think it's time to take out the oscilloscope. Now I hooked up my oscilloscope here directly to the lamp output of the dimmer, and what I can see right away, that the MOSFET gate isn't discharging perfectly. As you can see here, it has a little ramp here, so I could have made the value of the discharge resistor a little bit lower. Maybe it would be good to go for 8K or so, but other than that, it looks promising. And I tested the circuit with a 20 watt 12 volt light bulb, and as I said, the MOSFET stays stone cold, so there is no overheating. So I think I will leave it as it is. Here is the software code of the dimmer. It's pretty much a shift register. You see here I defined the push button on pin 4 and the MOSFET, the output of the microcontroller, on pin 0 on the ATTiny. Here is my integer for the counter, the step counter. Here I have my pin modes, again output, input as usual, and in the loop I simply read the button, give the reading a little bit of a time delay for debouncing, and I shift up my variable here by 1 digit every time when the button gets pressed. So for instance, this is step number 1, gives me a analog output. Step number 2 gives me again an analog output, and so forth till the last step where the output is full on or high. I've chosen a 300 milliseconds time delay between the steps. That's a good value for me, but you can change the values as well as the values for the brightness of the LEDs or of the lamp. It depends on what kind of light bulb you use. And in the last step, the lamp will get turned off and my variable goes back to 0 and the loop starts over. I will copy paste this sketch to the video description. If somebody of you is interested to make a dimmer like this, feel free. And I have left some extra cable length just in case, and now it's a matter of connecting everything together. And here is a trick which I use to make plastic standoffs for the circuit board. I use dowels, plastic dowels, and I simply cut the piece off of them like this and use these small pipes as standoffs. So the dimmer circuit is in place and the lamp is momentarily hooked up to my bench power supply, and here is the 5-volt signal wire going to a push button on the workbench. Okay, let's test it. Step 1. .6 watt. Step 2. 0.7 watt. Step 3. 1.2 watt. Step 4. 2.1 watt. Step 5. 3.5 watt. And full on, full brightness, 10 watt, so a bit under 1 amp, which is fine. Perfect. And to power the thing when it's installed, I want to use this SMPS 12 volt, 3 amps, so I think that's fine for the job. Okay, here it is. My chandelier is mounted in place and puts out a decent amount of light, actually too much when it's full on. And I have my teaspoon push button here. Off. 1, 2, 3, 4, 5, and full on 6. That's about halfway. Perfect. And yeah, I like it. It turned out very nice. And one word about the software. So, okay, I think you cannot see, but don't expect the analog write values to be linear, because the human eyes, the sense of light of the human eyes is not linear, so you have to play around with the values for the different steps till you get it right for your project or for your needs. And as you see here, I have a value 15, 22, 45, and the last step is high, which is 255 or high. So yeah, keep that in mind. And I think That's it for this video.